The initial breach would be silent, imperceptible. A microscopic singularity no larger than an atom breaches Earth's mantle and descends towards the inner core. Its immense density, a relic of primordial cosmic events, allows it to pass through solid rock as though it were empty space. Its gravitational influence initially negligible on the planetary scale. Upon reaching the nickel-iron heart of Earth, the micro-black hole's true nature begins to manifest. Its event horizon, though infinitesimally small, acts as an absolute boundary. Matter encountering this boundary is irreversibly drawn in, experiencing extreme tidal forces before being compressed into the singularity. Within the fierce pressures and temperatures of the inner core, the singularity's presence would initiate a localized, hyperdense gravitational anomaly. The surrounding molten metal and solid iron atoms would experience an unprecedented pull, distorting their crystalline structures and accelerating their motion towards the invisible point. The accretion process begins. Individual iron nuclei, subjected to extreme gravitational gradients, would be ripped from their atomic bonds. They would accelerate towards the micro-black hole, forming a superheated, rapidly rotating disk of plasma, radiating energy as they spiraled into the singularity's inescapable grasp. The energy released during this accretion process would be immense, a localized thermal output far exceeding the core's natural radioactivity. This surge of heat would propagate through the surrounding material, altering the convection currents that drive Earth's geodynamo, potentially disrupting the magnetic field. As the micro-black hole consumes matter, its mass would slowly increase. This growth, however minute, would incrementally expand its gravitational sphere of influence. The rate of consumption would depend on the density and availability of matter within the immediate vicinity of its event horizon. The Earth's inner structure would begin to deform. The relentless, localized pull of the growing singularity would create a cavity within the core, a void where matter once resided. This imbalance would subtly shift the planet's center of mass, initiating a slow, internal gravitational reorganization. The localized gravitational well and extreme heat would significantly disrupt the Earth's geodynamo. The turbulent flow of molten iron, crucial for generating the planet's magnetic field, would become erratic. Over geological timescales, this could lead to a weakening or even collapse of the magnetic field, exposing the surface to solar and cosmic radiation. Unlike a static anomaly, the micro-black hole would not remain perfectly still. Influenced by the slow, viscous flow of the outer core and the planet's rotation, it would exhibit a subtle, wandering motion. This movement, albeit slow, would carve a path of destruction, gradually incorporating new material and distributing its gravitational stresses. As the core's integrity is compromised, seismic activity would intensify. The immense stresses from the localized gravitational distortion and the internal movement of the singularity would trigger deep focus earthquakes. These would be unlike tectonic events, originating from the planet's very center, radiating unprecedented shockwaves through the mantle. The accretion rate, though initially slow, would define the planet's fate. While only a tiny fraction of the core's mass is consumed daily, the process is relentless. Over millions or billions of years, the micro-black hole would systematically devour the inner and then outer core, transforming the planet's thermal and structural engine. The gradual shift in the planet's mass distribution would introduce a subtle, long-term wobble to Earth's rotation. This change in precession and nutation would be imperceptible to direct observation for millennia, but its gravitational signature would incrementally alter the planet's orbital mechanics within the solar system. Compared to natural geological processes like mantle plumes or subduction zones, the micro-black hole represents an entirely alien force. Its interaction with planetary matter is governed by fundamental spacetime curvature, a phenomenon far beyond any terrestrial geological stress or thermodynamic equilibrium. The energy radiated from the accretion disk within the core would dramatically increase the planet's internal heat. This excess energy would drive more vigorous, albeit chaotic, mantle convection. Volcanic activity and widespread geological instability on the surface would become more frequent and violent, a delayed surface manifestation of the deep core crisis. Ultimately, the micro-black hole's presence in the core would signal the planet's long, slow demise. The core, the Earth's heat engine, and magnetic shield generator would eventually be replaced by an ever-growing, super-dense singularity, transforming the once vibrant planet into a dead, geologically inert sphere orbiting its star. The Earth's crust, comparatively fragile, would not immediately register the deep core's turmoil. However, the escalating internal pressures and shifts in gravitational equilibrium would lead to unprecedented crustal stress. Fault lines, previously stable, would activate with increasing frequency and magnitude, altering global tectonic patterns. Unlike the gradual cooling and solidification of a dying star's core, the process initiated by a micro-black hole is one of active consumption and thermal escalation. The core doesn't simply cool, it is systematically dismantled, releasing immense energy as matter yields to the singularity's gravitational dominance. The scale of this event dwarfs any known terrestrial catastrophe. A supervolcano eruption releases gigatons of material. The micro-black hole would, over geological epochs, consume quadrillions of tons of planetary matter, altering the Earth's fundamental composition and mass, subtly affecting its orbital velocity. As the singularity grows, its gravitational pull would extend further outwards. The mantle, a viscous layer of silicate rock, would begin to deform under these new stresses. Plumes of superheated material would ascend more rapidly and violently, causing widespread crustal thinning and increased magma output globally. The planet's magnetic field, already destabilized, would enter a period of rapid decay and reversal. Without the consistent churning of the liquid outer core to generate its dynamo, the field would weaken to a critical point. This would expose the atmosphere to solar winds, leading to atmospheric stripping over eons. With the core's destruction, the primary source of Earth's internal heat is replaced by the localized, intense radiation from the accretion disk. This change in heat distribution would fundamentally alter mantle convection, causing widespread surface subsidence and uplift as the planet's internal architecture collapses. The relentless consumption of the planet's interior would eventually lead to a significant reduction in Earth's overall mass. This mass loss, though distributed over an immense timescale, would cause the planet to slowly drift further from the Sun, altering its orbital period and potentially its long-term habitability. The internal gravitational collapse would not be instantaneous, but a protracted, agonizing process. The once dynamic layers of Earth would become increasingly static and inert around the growing singularity, a planetary corpse slowly consumed from within, its vital functions extinguished by an alien cosmic entity. The Earth's surface would experience increasingly violent geological events. Supervolcanoes driven by chaotic mantle convection and immense internal pressures would erupt with cataclysmic force, releasing vast quantities of ash and gases, radically altering global climate patterns and atmospheric composition. The continuous mass loss and internal structural collapse would fundamentally alter Earth's gravitational field. Precise measurements would detect anomalies, indicating a shifting, weakening pull. This would manifest as subtle, yet persistent, changes in orbital mechanics for satellites and lunar interaction. Over hundreds of millions of years, the planet would transform. The vibrant, dynamic core would be replaced by an ever-growing, super-dense sphere of pure space-time curvature. What was once the engine of life would become a quiescent void, silently consuming the remaining planetary mass. The magnetic field, once a robust shield, would effectively vanish. Without its protection, the solar wind would directly interact with the upper atmosphere, causing significant atmospheric escape. The planet would slowly lose its gaseous envelope, resembling Mars in its exposed, barren state. Tectonic plate movement, driven by the core's heat, would cease. The planet's crust would solidify into a single fractured shell. Mountains would erode, and new ones would no longer form. The Earth would become geologically inert, a dead world with no internal heat engine to drive its surface processes. The once molten outer core would eventually freeze and solidify or be consumed entirely. This loss of liquid iron would erase any remaining semblance of a planetary dynamo, ensuring the permanent absence of a protective magnetic field around the dying world. The subtle gravitational influences of the growing singularity would propagate outwards, affecting the entire planet. Over eons, even the deep oceans would become perturbed by the changing gravitational field, leading to unprecedented tidal stresses and potential large-scale oceanic displacements. The Earth's surface would become an increasingly hostile wasteland. The atmosphere, thinned and bombarded by radiation, would no longer sustain liquid water on the surface. Oceans would evaporate, and the hydrological cycle would cease, leaving a dry, desolate landscape akin to early Mars or a moon of Jupiter. Life, in its complex forms, would be extinguished long before the planet's total consumption. The loss of the magnetic field, extreme geological instability, and radical climatic shifts would render the surface uninhabitable. Only extremophiles in deep subsurface environments might persist for a time, shielded from the surface catastrophe. The relentless atmospheric stripping would continue until only a tenuous exosphere remained, composed of the heaviest gases and trace elements. The blue marble would transform into a gray, airless sphere, its vibrant colors replaced by the monochromatic hues of cosmic dust and ancient rock. In the vastness of cosmic time, the Earth would become a planetary relic, its once dynamic interior replaced by an alien singularity, its surface scarred and lifeless. It would orbit the Sun as a silent monument to an irreversible cosmic intrusion, a stark reminder of the universe's indifference. The micro-black hole, having consumed Earth's entire solid and liquid mass, would persist. Now slightly more massive, it would wander through the vacuum, a silent, dark remnant of a destroyed world. Its existence would be a testament to the enduring destructive power of fundamental physics. Such an event highlights the profound vulnerabilities of celestial bodies. Planets, though seemingly robust, are intricate systems reliant on specific conditions. An unforeseen cosmic visitor, even one infinitesimally small, can initiate a chain reaction leading to total planetary collapse. The cosmic void is not truly empty. It harbors phenomena beyond immediate human comprehension and detection. Micro-black holes, remnants of the Big Bang, or products of high-energy cosmic collisions, drift silently, their gravitational influence a potential harbinger of unfathomable change. Understanding such deep-seated planetary destruction forces us to ponder the true resilience of worlds and the delicate balance required for habitability. Our planet, a beacon of life, exists within a universe where fundamental forces operate on scales both grand and imperceptibly small, dictating all fates. What does the thought of a tiny, unseen gravitational anomaly silently consuming a world from within teach us about the profound, often terrifying, mechanics governing all celestial bodies in the silent cosmos?